Alright, so here we're going to do another washer method problem. It says rotate the region contained by y equals x squared. We know that parabola. Also, x equals 0 and y equals 1. And we're going to take that region around the x-axis and find the volume. So the best thing to do is to start off by drawing a little picture graph so we can see what we've got here. So let me see here. I'm going to come out to x equals 2 and negative 2 for fun, and I think I'll go up to 4 on the y-axis just to draw the parabola. But let's see here. The parabola, we know what it looks like: 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So whether I need all this information, I have the y equals x squared shape. And then I also need to bind it by x equals 0, which makes sure you understand that that is the y-axis. Okay, that is the y-axis, and we're also going to use y equals 1. So y equals 1 is right here, and the x equals 0 is over here. So we got a little region partly between 0 and 1 for x and 0 and 1 for y, but we don't have the whole thing. So this is the shaded region that's trapped between all those, and we're going to rotate that, as it says, around the x-axis. So when it comes around, it'll look like a three-dimensional figure, kind of like I've got here. But you got to keep in mind that it will be a revolution. So I don't know that I can really draw that very well, but it's not just a flat triangular shape up top and a flat triangular shape at the bottom that's spun around the x-axis, so it creates kind of like a I don't know, a hollowed out cheese wheel, if you will, in a way. But anyway, we're doing this thing in terms of x, so let's write our equation. Volume equals pi, and we're integrating in terms of x, so we need our boundaries in terms of x. So the way this thing looks, it goes from 0 to 1. Okay, that is where it would intersect the parabola over here. So the outer region, as we go around there, would be the y equals 1 line. So the outer radius would be 1. And then the inner radius would be, let's see here, the x squared here. So the x squared squared dx. So here I have the outer and I have the inner. Okay, outer being a radius of 1, the inner being a radius of x squared. Both of those are going to get squared, so let's just kind of roll with it and clean it up. So my integration is pi from 0 to 1 of 1 minus x to the 4th dx. That's really easy to integrate. So if we've set it up right, everything will work out really good. So integration, we'll leave the pi on the outside, 1 becomes x, and then when we integrate negative x to the 4th, we get negative 1/5 x to the 5th, and we're going to integrate this from 0 to 1. So let's plug in our endpoints. Let x equal 1, so that will give me pi times 1 minus 1/5. Then we'll subtract off, let x equal 0. That'll be pi times 0 minus 0, so this whole last part's gone. So it looks like I will get 4/5 pi. Okay, and we might be able to draw some conclusions from looking at the figure and make a better calculation off of it. But that's what would happen if we rotated this thing all the way around. Okay, so let's see here. I think I've got one more that I want to talk about here. Find the volume of the region bounded by y equals 4 minus x squared and y equals x plus 3, and I'm going to rotate that around the x-axis. Okay, so let's see here. 4 minus x squared, so that is an upside down parabola up at 4. And I believe by the time I get around to it, it has the points 0, 4, 1, 3, and 2, 0. And then on the other side, if I need them, negative 1, 3, and negative 2, 0. So an upside down parabola, I may not need the whole thing. But this is my y equals 4 minus x squared. Okay. And then let's use a different color for the y equals x plus 3. So that has a y-intercept of 3, and it goes up to a slope of 1, so it goes up to 1, 4. But I can also go backwards, and it goes backwards to, let's see here, negative 1, 2, and negative 2, 1. So coming through here, that is the y equals x plus 3. And I'm going to rotate that around the x-axis. So I'm really taking this sliver of space in between here. Now, this is not going to be the hardest thing in the world, because we know we're going around the x-axis, so we want everything in terms of x, but let's see what we got to figure out. So we got volume will equal pi for the rotation, and we need limits of integration, so we need an a and a b. Well, let's get that in a second. Let's see here. So the outer radius from where we're going goes all the way out to the parabola. So that would be 4 minus x squared for the outer, and then minus the inner, which is x plus 3. So we've got some stuff to square and then clean up. We've also got some endpoints to find. So we can look at this, but I'm not really sure. Let's figure out where these things intersect for x. So one thing we can do there is figure out where they have a common point. So I can take the 4 minus x squared and set it equal to the x plus 3. And if that's the case, I will get the x's where they cross, where it's like a system of equations. Where do they end up at the same point? Because they'll have the same x, and since we set them equal to each other, they'll have the same y. So let's try and do this. I'm going to bring everything to the right-hand side because I don't like a negative x squared. So we'll leave nothing over here, but I'll bring the x squared over, so it'll be positive x squared plus x minus 1. Is that right? Yes, so that is no fun at all. I don't know if I should have used this problem or not. I don't know why it would be so hard, but let's see here. I don't think that thing factors, so let's say x equals negative b, so negative 1 plus or minus the square root of b squared, so 1 minus 4ac, so minus, so that'll be plus 4 all over 2a. Yeah. I probably should have worked this a long time ago before we got here. So I get negative 1 plus or minus the square root of 5 over 2. I'm going to use my calculator to see what those are, because I feel like I'm just going to estimate it at this point. So negative 1 plus the square root of 5 and divided by 2. Looks like it gives me 0.62 is my estimate. And negative 1 minus square root of 5 divided by 2 gives me negative 1.62. So just looking at our graph, that seems about right, even if I don't like the numbers. So over here, where they touch, that could be about 0.62. Looks like it's between 0 and 1, so it could be a little bit more than a half. And on the other side, negative 1.62. It does kind of fall right here, okay, between negative 1 and negative 2. My graph is not the best, so who knows where it's supposed to be exactly on the graph. But we'll put those in here and hope for the best. We're going to ride this one out. So pi, and then from negative 1.62 to positive 0.62. And I need to FOIL things out. So what do we got here? I'm going to FOIL the 4 minus x squared, so I'll have 16 minus 8x squared plus x to the 4th. And then I've got to subtract off foiling the x plus 3, so that'll be minus the quantity of x squared plus 6x plus 9. So let's do a couple of cleanups here. What do we got? We've got an x to the 4th. We've got a negative 8x squared, and we'll have a negative x squared, so that'll be a negative 9x. Excuse me, that was x to the 4th. Negative 9x squared. And then with the x's, we have a negative 6x. And then we have 16 minus 9. So that'll be plus 7. Fun stuff. Let's see. Double checking all that. X to the 4th. Negative, negative. Minus. I think that's right. So let's see here. I think I need to move my face. Give us just a tad bit more room. So let's see here. When we integrate this, we'll have a pi on the outside. It'll be 1/5 x to the 5th minus 3x cubed minus 3x squared plus 7x. And that'll run from my negative 1.62 to my positive 0.62. So I'm going to do this. I'm going to pause the video and throw all the numbers in and see what happens. So when I let x equal 0.62, I'll get a number, and then I'm going to subtract off letting x equal negative 1.62, but in the interest of time and space, I'm just going to pause and put those numbers on the calculator. So let's see what happens. Okay, playing with the calculator, let's see if we can get the same thing here. But pi times plugging in 0.62, I got 10.24 approximately, and then minus, and plugging in the negative 1.62, I got a negative 10.81. Now that is after multiplying by pi. So two negatives on the second one means I'm going to add them together. So 10.24 plus 10.81. Looks like I'm getting a total volume here of 21.05. Now, of course, that's approximated since I rounded everything off. And you may wonder how that could be, because it doesn't look like a big region there. But remember, we're wrapping this thing around, and the further it is away from the axis of rotation here, the more space it's going to take up. So even if it's a small region, if we push it way far away from the center, when we wrap it around, it'll just be huge as far as the radius. So if we find any problems with that numbers, we'll look at it. But 21 is about what I get here. So we'll go with that for now.